let me scroll up to the top here. You see we got a lot of containers running in our main Modal Labs workspace. We do a lot of stuff there. Continuous monitoring. We have a bunch of integration, analytics, dog fooding on our platform. Kind of why we make sure the debugging experience is good. We're able to debug our own stuff that we've built on our platform. One of the things that really got me excited about Modal when I first started using it was just how easy it was to develop applications that involved using a bunch of cloud resources, remote file systems, hardware that I didn't have locally, like GPUs. If I'd used some other cloud platforms in the past, you'd use SageMaker, and very frequently, like when the happy path was being followed, everything was great, and I could run and deploy my applications. But as soon as something broke, it was really, really hard to figure out what was wrong, how to fix it. I needed to develop a really good mental model of the infrastructure I was working on to be able to do anything. And because I needed to change code in order to change the deployment, and then I would then the bug would show up, or then the issue would show up. And so you have to do a lot of reading ahead of time the documentation, carefully planning what you're going to do, rather than sort of iteratively, interactively debugging an application, which is kind of my preferred way to do it, having come from the sort of research world, from the Jupyter notebook kind of world. So I wanted to walk through all the different features of Modal to kind of support this much faster iterative approach to development and debugging. So I'm planning to get through 4 of them. So we're gonna have to jump in and go pretty quick in this 40-minute webinar. So I'm gonna go through Modal Container Exec, which allows you to kind of get in there and tickle a live deployment and see what's going on inside it and change it. I'm gonna go show Modal Shell, which is a great way to just get kind of a simple environment in Modal, so you can test your assumptions or your hypotheses about things. Modal Launch Jupyter, which allows you to just quickly spin up a Jupyter notebook interface that has access to some resources that Modal provides. So it has access to a remote file system, access to a GPU, and kind of supports kind of iterative development with persistence for when you're trying to explore something where you want visualizations maybe, and the terminal isn't going to cut it. And then lastly, Modal breakpoint debugging on Modal with Modal Run Interact. So you don't have to give up on your breakpoint debugging style just because you're doing development on Modal Cloud. So, all right, let me switch over to my VS Code terminal and dive in. I'm going to pull up the Fast API, or rather Open API / Swagger doc for this this LLM endpoint. So that's pulling up there. We can see, let's see, we're watching the containers cold starting here. It takes maybe 30 seconds to boot on this one. We're getting the Llama 8B model loaded and ready to go in an LLM server. So what we're going to do is I need to find the container that it's running on, and the command for that is modal container list. Let me make a little bit more space for that in VS Code, make a little less space for the other side, modal container list here. So modal container list is a command that shows you all your running containers. So let me scroll up to the top here. You see we got a lot of containers running in our main Modal Labs workspace. We do a lot of stuff there. We do everything from continuous monitoring. We have a bunch of integrations, analytics that we all run, dog fooding on our platform. That's kind of why we make sure the debugging experience is good. We're able to debug our own stuff that we've built on our platform. Okay, so that's what modal container list does. It gives you an ID for the container, an app ID for all the applications that are currently running, where you've spun something up on Modal. And by interacting with this documentation, I spun up a container. So there should be one in there. I'm going to do JSON mode output. This is nice if you've got if you have JQ for JSON on your machine, but for querying. But actually, I'm going to do a kind of simpler query here to just pull out. I'm going to grep for the app name. It's got VLM in the app name. I'm going to grep with some before and after to pull out this is the app name with its container ID and that output. Bunch of different ways to interact with that output. That's just one that's kind of flexible, uses tools that I'm comfortable with and familiar with. So that's what I kind will do when I need to get a hold of the container ID. So this container ID is like this specific like instance, this specific replica of the service that we can interact with from these docs, or that we like these are like API docs to like test out, try out this backend. So let me type in the super secret token so I'm authenticated with it and can confirm this thing is up. Let's execute it. I love these. Like, speaking of like cloud native development and debugging, I really love these Swagger docs. They're open API docs that you get like for free with Fast API by just like turning on the doc flag. Super useful for this, for like trying out a couple of routes quickly, or like iteratively developing something. Okay, so let's get into this container. So the command for that is modal container exec, and actually let me just do modal container exec with the help flag. So it wants a container ID and it wants a command to run. So there's lots of things you could do. Like you could just do ls. Oops, I copied the name of the app and not the container ID. Oops. Right, so that container ID is the thing that I actually wanted. All right, so we want that container ID. You can run anything in this container. So like, ls, you can just like run a one-off command. Oh, there's actually some more features of modal container besides just like, I showed list and I was starting to show exec. But one fun one is modal container logs. If you want to find like if let's see, if I hit execute here, I should see some server logs pop up. 200. Maybe not. Maybe I'm looking. I think I'm looking at the container for not for the Open API component, but for another piece of that. So we won't see the logs there. But if you attach to the right, container, you can tail the logs and watch them. So you don't have to go to the Modal UI for that. And so you get them like back in your terminal. If you've used like Modal Run, for example, or Modal Serve, you've seen logs in your terminal. You can get that with deployed applications with Modal Container logs. But that's not what we wanted. What we want is to dive in on this container. So now here we are. Oh, I see the problem. All right, so this is this is one reason why I really like this like iterative development style. You can discover the issues. So I landed on the container. I'm in the root user's home directory, is what that prefix means. Root at modal and twiddle for home directory. I do ls to get my bearings. Where am I on this machine? And I see VLM_Mistral. And wait a second, if I look over here, this says MetaLlama 318B. This is not, that's not Mistral. Wait a second. So this is not actually the code that I wanted to be running. When I grabbed the container ID, I grabbed the wrong one. I grabbed the container ID for a different container also running VLM. So let's go back here to this example, VLM Mistral. I must have grabbed this container ID instead of this container ID. Now let's try modal container logs for this one. There we go. That looks more, you can see the health checks in there. Let me run another health check just to confirm that. All right, there we go. So it wasn't that I was pointing to the wrong component of this application, which might have multiple containers in it, but rather that I was pointing at the wrong application entirely. But yeah, so now we can see our logs showing up there, and but with logs, you can't do anything. You can't interact. You can just watch what's going on or search for what happened in the past. So let's go back to, let's do that modal container exec command now with the right container ID. There we see VLM inference. That's what I expect to see. That's the name of this code. So let me zoom in a little bit more. All right, so so some things you can do once you have the shell. One, you can check out the file system, check out what's going on. That llamas folder that you can see there, the llamas folder has the model files in it, so we can find the llama 317b instruct and 8b instruct. So this is a distributed file system. So this is something that's like that can be attached by many modal workers, by different replicas, by maybe multiple applications that all need this, like to use llama models, and you can kind of like poke around and play with it here. You can make edits if you want. So that's a nice feature. Another one, like, let's check how that GPU is doing. GPUs are expensive. You want to check in on how they're doing. You give us a little bit more space. The output there is pretty wide, very wide. There we go. All right, NVIDIA SMI, great, nice and clean. So we can see we're on an A100, a 40 gigabyte A100. We can watch the power usage and the memory usage. That's cool. Like maybe let's watch a query come in live, and like hit this endpoint, like kind of get ourselves to like check that this endpoint is running. But in order to do that, actually, like when you're debugging something, often you need stuff that's not available, that you wouldn't want to install in like every instance that you're running, because it's going to make your like container image startup or your image build slower, but you want it when you're debugging. So an example is like I kind of want to run like a couple of terminals in this. But if I try and run something like Tmux, it's not installed. We have this very slim image, doesn't have these things in it. So let's install Tmux so that I can have a couple of windows open. Cool. And just to show you that this works like just like you would hope, I'm gonna detach from that session and then like go back into the, now I'm going back into the container. I went back to my like local machine. I'm now back in the container, and I can Tmux attach, and I'm back in that same session. Cool. And let's see. Let's watch NVIDIA SMI. A couple of nice commands here to make it look pretty. I'm watch commands that like kind of reruns the command over and over again. I'm saying to rerun that command every 2 seconds to highlight differences and to not wrap any text. Oh, watch isn't installed. Well, let's just install watch while we're here. Great. All right, there we go. All right, so now we can see, great. So it's we can see the time is changing there. So you see the little highlight. Let's see, looks like that output got a little bit mangled, little terminal noise there. So let's try that again. Dang, you can see, you can't see the top of that. Let's try without that no wrap. I might need to zoom out a little bit. Okay, without the no wrap, and it still looks fine because I had made this window nice and big. Okay, cool. So now we can see like now we can see the whole of what's going on with the GPU, and we'll be able to watch that change once we get a request coming in. Maybe like open up another window. Let's do top if we want to check in on things. Top is kind of ugly. Can we install htop? I bet we can install htop. There we go. Htop looks a little bit nicer. There we go. Now we can see what's going on. Lots of stuff going on in the background on this guy, but looks like not a high load, so we'll be able to watch that change. Cool. Anything else? No. Yeah. All right. Let me. I'm now gonna switch back to and pull up. Well, first I'm gonna go over to our NVIDIA SMI. There we go. All right. And let's see. What are the available models on this one? Let's see. The only one should be this Meta Llama 3.1 AB Instruct. The only engine we spun up. Okay, now I'm going to go to the completions endpoint, and I'm going to like hit this endpoint with a prompt. Like, once upon a time in San Francisco, comma. Great. So I'm gonna try and hit this endpoint with this. So these Swagger docs like come with example inputs, but the example inputs are only as good as your schema. They try and guess what like good default values are unless you provide an example option. And unfortunately, the schema for this one's pretty complex, and so it's like kind of hard to express what what the default values should be in JSON schema. So I got a 422 error with this one. I could probably see that if I did with modal container logs, but rather than do the modal container logs thing, Actually, here, let me show you. Here's a fun one. So we don't have Modal installed on this thing. We don't install Modal all like in the application that you're running, but you can install Modal on the application that you're running. And so we can actually do Modal, like I just installed it. So yeah, python-m Modal container. There we go. Python-m Modal container logs. Missing argument container ID, right? We'll need that container ID. So let's do python-m modal container list and grep-a2-b2 VL1. So we'll find this container on modal to, let's see. Ooh, do we not have grep installed? That might be a problem. Oh no, we have grep installed. Let's try that again. grep-a2-b2 VLM. Interesting. Getting more output than I expected there. Oh, right. Let's do what I really wanted was -json so that I can pull that out. Great. Yeah, I love this sort of like more interactive style, like discovering things as you go. All right, so now what I'm going to do is get the logs for this container from inside the container. So python-m modal container logs, drop that in. Great. Okay, so now we can see that 422 error showing up in the side. All right. Not the cleanest looking logs, I'll say that. This is maybe tightly zooming in on stuff while in Tmux in a webinar does make it a little harder to make this look like nice and clean, but I promise that it does look decent when you are when you're doing this nicely zoomed out. Okay, let's see. Let's maybe declare a little bit of bankruptcy on that one and retry it. There we go. So now that's showing. And let's restart that htop command. And yeah, we're good to go. All right, so we got a 422 error, unprocessable entity. Luckily, we get some good error messages from this. Stream options can only define when stream is true. So we look up at all these options that got added. We have stream is false, but we included stream options. So this default example wasn't quite what we needed. So let's drop that. We can also just kind of look through what are these additional props. No, that looks like junk. We don't want logic. Best of the default value for that parameter is 1. Getting closer. Is this gonna run? 422 error. Oh, you can only use one kind of guided decoding. Another error there. Okay, that's not right. Let's drop all these guided outputs of LLMs. Like, don't just output arbitrary text. Let me tell you what tokens are allowed at each point. So like you always output valid JSON or something. Oh, and do we have a 200? No, we have a 422. Truncate prompt tokens. Input should be greater than or equal to 1. That I don't think we should send that one at all. I think we should probably just not send that truncate prompt tokens. Yeah, we don't need that. Min token 0, those all look good. The other ones look like they'll give the right default. Suffix is not currently supported. Oh yeah, the VLM OpenAI compatible mode doesn't quite nail every aspect, I think. So let's drop that one. We're still going. Server response 200. There we go. Once upon a time in San Francisco, there was a man who devoted his life to creating a medical system that could contemplate. And that man's name, Sam Altman. Great. So why did let's go back and look. Can we see that we ran that on this particular machine? I'm gonna squeeze this a little bit. Looks like a little bit of wrapping there. There we go. I'm now gonna run this again, and I want you to pay attention to the terminal on the side there while we're doing it. I'm gonna boost the number of tokens up to like 1,000, and then we'll see that GPU heat up. So there we go. All right. Watts going up from a few tens to a few hundreds there briefly. GPU utilization going up. So we can see we ran it on that instance, and we can debug the behavior of it. Let's maybe, oh yeah, if I do like n equals 10, that's another one that'll like really run, that'll run for longer. We should see, ooh, best of must be greater than or equal to, right, that best of parameter. Let's drop that best of parameter, so it causes us trouble. Great. Okay, now we're running 10 requests on here. We can check the logs and see our like prompt throughput and the activity of this server. We can check htop here. Let's see, we see those running. It's a little messy switching between these tmux tabs. Maybe probably just like a setting I need to change in tmux to make sure that it wipes those things each time. All right, so we can watch a request go through. You can so like we're live on this container that's serving requests. If this were your like production like a production replica that was having trouble, you could like debug, figure out what's going on inside it here. Cool. So let me detach and exit. And yeah, I think that's everything I wanted to cover for modal container exec. So that's the key offering for being able to like poke around inside your inside a deployed modal application and like debug it live. I'm going to quickly show modal launch Jupyter for doing kind of like data science-y tasks on modal. So let me show you the syntax for that command. Okay, so the idea with this modal launch Jupyter command is that you can get a Jupyter instance that has access to like resources defined on modal. So it's like quickly getting like the mounting your code. That's this one. So like make sure that it has a GPU acceleration or that it has a distributed volume available. So the example I'm going to show you is something I used for data science on kind of the New York Times archives. I was pulling New York Times articles from 30 years ago and like pulling them down as an archive, and it's this like kind of messy JSON format, and I wanted to kind of like explore that. So let's do that. The name of the volume is NYT headlines. So I can launch Jupyter with that volume attached, and then I can work on like a one-off notebook if I just want to like quickly test something. Like I want to like just like make sure some library works while I'm developing something else. Or I can save onto that volume a notebook, and then when I come back to that volume later, that notebook's available for me. So that's what we're seeing here. Let me make this zoom in a bit so things are a little bit easier to see. So this volume here has the New York Times articles. It's from 1995 from the Twitter 95 project that I've been working on. It's got articles from 1995 in these little JSON files, and then it's got an analysis notebook for looking at those archives. So yeah, make sure we got the environment available that we need to interact with this. And right, so now I'm in this Jupyter notebook running and interacting with the data that I have in this distributed volume. So these articles are read from another component of this system. It's kind of like it's a fake social media network and like set in 1995, and I'm just injecting these old articles into that social media network to sort of like keep it in 1995, keep it up to date with what's happening. So I can examine the like state of that archive. I can play around with that. I can edit it from this notebook without interfering with the rest of my like production architecture or like the stuff running in production. So there's some interesting kind of like fun stuff here. Like why do I why use the Jupyter notebook? Like why do you need this? Like why not just like write queries? The reason why is like this is a pretty messy archive that I pulled down. So like for example, there is a news desk called Automobiles that has one article, it looks like. I'm doing a quick group by like news desk that's like there's a sports desk, this book review desk. I was using this to try and like kind of split out components of this archive that might be interesting to like different fake users on this social media platform. And So that's these news desks, and some of them are misspelled. They have non-canonical spellings in different places. And so like this is the sort of thing that you can only discover. Like this is not something that is, there's not a schema that I can point to. It's like pretty hard to predict that these might be problems. So frequently you kind of want to like explore this thing to like find those kinds of potential bug causing issues. Another one is it's just like this is a like this is data that I'm going to inject. I'm showing it to a bunch of LLMs. I need to kind of know what this data looks like. I want to explore it on like kind of a qualitative level. So I want to have like little things for like pulling out information from the data and looking at it in a rich interface like a browser, for example, to pull up these New York Times uh, archive articles and like review them and look at them. And like it's frequently like at least in my experience with this kind of like messy data you're pulling from various like APIs, you are better off in this like rapid iterative environment than you are like trying to like just plan stuff up front and and like work in a like in a shell with script kind of format. You like move more quickly. So I did a lot of work in this notebook to kind of like write code that ended up added to the actual application for sort of like filtering articles, prioritizing articles. This all works nicely in this notebook. Let me just show you that like this stuff is persisted. You probably believe me, but I'm gonna say like print hello from the webinar there. Save that. Now I'm closing that script, shutting down that Modal launch Jupyter, and then running it again. It's gonna drop me back in to that Jupyter instance in a second, and we'll see that that change is persisted. All right, there we go. There's our analysis notebook, modified 22 seconds ago. Hello from the webinar. Great. Let's remove that because I don't actually need that. Great. So yeah, Modal launch Jupyter, great for kind of like exploring the contents of these volumes, these distributed file systems, like kind of one-off testing stuff. Let me show you the breakpoint debugging in Modal. Let's just start a new debug.py. I'm going to show you just really quickly how to do this like interactive debugging on Modal, right? Like with cloud deployed infrastructure, it's often hard to get your like debugging tools that you're used to using working because the like computer that's running the code is far away. And so with Modal, you don't have to worry about that. Let's do app.function here. Let's add one. And let's add just like a very silly function, your classic hello world. Let's define some local variables so that we have something to look at once we're in our debugger. And then we'll have a print statement there. Okay, so now let's just modal run debug.py. There we go. All right, citation target. Also, just like a side note on like, just sort of developing on Modal and figuring stuff out on Modal, like writing these kinds of like super short snippets. We do a lot of work to try and make it easy to write a short snippet like this. For example, you don't need to name an app. You don't need to define an image for an app. We'll like just pick a default Python, like same Python version you're running and a default Linux image. So like you just trying to keep the like number of characters, number of lines of code, number of things you need to think about and like pull into your brain and have in your context. Keep all that as minimal as possible if you just want to like try out like one feature at a time. So in this case, that's like this interact and debugging stuff. So like getting breakpoint debugging working is as easy as just like calling breakpoint. With one exception, you have to pass a flag saying that you want to interact with this function. So this modal run -- interact. Sorry, interactive. Sorry, I usually use the short form with like -i, single character I. But yeah, the long form there is -- interactive. All right, so we're spinning up a container, running the function, and then we're going to drop in at that breakpoint where we have like a full Python debugger. There we go. So salutation. We're at line 10. We can see that, yeah, there we are. Salutation, target, great, hello world. We can change salutation to a different value. We can change target to a different value. Yeah, cruel plus target. We can inspect those variables. Great. Yeah, goodbye. And then, like, once we're done with our debugging, hit continue. There we go. Goodbye, cruel world. So this, like, actually great feature of Python, I think, to like, compared to other languages, you can actually edit the environment while you're doing breakpoint debugging. You can like really go hog wild. And so, like, that makes this a really powerful debugging tool because you can do counterfactuals. You can be like, well, what if I had set this variable to a different value? What would happen then? And like, so that makes this like a particularly like kind of like powerful form of debugging. So, you know, we want to make sure that we support that on Modal. So that works with Breakpoint. Breakpoint debugging is fun, but the like as you may have seen, the like editor there is like pretty minimal. It's a very old school backend kind of text environment. Even more fun is debugging in an IPython REPL. So if I do import IPython.embed and then run interactive, I'm going to end up in an IPython interpreter that has access to the local variables. Or I would if I had installed IPython. So let's make sure that's installed. I'll frequently add those kinds of little. Oops, that's an app. You can't pip install in an app. So now we do need an image. So modal.image.debian.lim.pip install IPython. Great. So that should do it. Right. So yeah, I frequently add like little pip installs, app installs at the end of images when I'm doing like modal run debugging or when I'm modal shell to access a particular function's environment. And let's see, is that working? Modal run dash interactive should be. Let's try that one more time. Oh, you know what? So when you want to open a terminal, there is, I think, one more step that is required that's not required for the breakpoint. We have a little bit of magic to avoid that. You need this modal.interact. So yeah, so when you want, so IPython is not the only thing that you can use here. You can do you can do other kinds of REPLs, other kinds of like keyboard interaction stuff. But yeah, so you do need that modal.interact to be able to use it. There we go. So now we're in that IPython REPL. And we should have access, not salutation, that's not defined. Salutation. There we go. We have everything else. So let's see, salutation equals. I don't know if you can actually do the same like counterfactual style editing that that I was showing there with the breakpoint debugger. Let's find out. Can I change salutation and see that affect the rest? Looks like not. So yeah, the IPython REPL is more for like kind of like richer interaction, like richer like a richer environment for inspecting those variables. So like if that was a pandas data frame, maybe I'd want to like explore through that data frame. That's kind of painful in the base Python debugger, but it's really nice in IPython. So the debugger and the IPython REPL, that's for like inspecting inside of a function, like dropping into the middle of the execution of a function and exploring what's going on. The modal container exec is for getting inside the container and sort of being at the kind of like operating system level at the oh, I want to like spin up some extra processes that are on the same like machine. In between those is like, okay, I want to get into the like environment that this function is running in. I don't need to be like in the middle of a function and I kind of want to poke around. Like maybe like, you know, similar to Modal Launch Jupyter, where you want to like maybe look at remote file system or like look at how a library works. So the way to do that is with modal shell. So this is like modal container exec with bash, but it spins up a new replica, so you don't interfere with your production infrastructure. So it's like do modal shell debug.py. And now we're going to land in this function, like same environment. So I should have IPython, for example. So like same pip environment, but not like the actual, like executing function. Great. And let's see, are there any other good features of modal shell? Yeah, you can do region pinning, GPUs, volume. Yeah, those are nothing super fun. I guess the other thing is like, yeah, if you just want to like quickly test whether something's going to work in a GPU environment, like modal shell, that's just GPUs. Like, I don't know, the fastest way I know of to like start running something on a GPU, like 20 characters. We got that GPU. You can do something like you can try to like pip install some like complicated library like sglang. And you might get error messages here. The nice thing about doing environment setup or installations on a modal shell is you can see error messages that come out, and then rather than having to rebuild the image every single time, which is what would happen if you were trying to do build an image, define an image like I did here with pip install IPython, but with many packages and you're running into errors, you need to rebuild it every time you hit an error. And you can't once an error happens, you might want to poke around and figure out why the error happened. That's something you can do in a shell, but you can't do if you're just triggering our container build. Running short on time, so I don't think I'll go through I use this to figure out how to install flash infer, which is a fast flash attention style kernel that this sglang library uses, and it's got kind of painful installation process, as is frequently the case with custom CUDA kernels. And yeah, I used figured everything out here in this shell interface, and then just copied and pasted the results into a file. I can actually show you that one really quick. Sglang and debug. Right. This one wasn't too hard. I think flash attention was a little bit harder. But yeah, there's this kind of custom pip install command with this particular wheel, and getting that working took a little bit of doing. Another thing, you can also, with these shells, just like with modal container exec bash, you can install things along the way. So you might install something like tmux to help you run things in parallel while you're doing your build, which is faster iteration than you would get from from the normal programmatic interface. But I won't go through that because we're running out of time on this webinar. 4 different ways to do debugging and cloud native development on Modal, optimized for speed and iteration and interactivity.